guys, welcome back to my channel. So for today's video, I'm going to share with you the content and summary of what I've learned in CCNAv7 Module 12. So to start with, the Module 12 WLAN Concepts or WLAN Concepts. What will I learn in this module? So the module title, as you can see here. The objective of this module is to explain how WLANs enable network connectivity. These are the topic titles and the topic objectives. So first, Module 12.1, Introduction to Wireless. Describe WLAN technology and standards. Benefits of wireless. So, benefits of wireless. A wireless LAN or WLAN is a type of wireless network that is commonly used in homes, offices, and campus environments. Network must support people who are on the move. People connect using computers, laptops, tablets, and smartphones. There are many different network infrastructures that provide network access, such as wired LANs, service provider networks, and cell phone networks. But it's the WLAN or the WLAN that makes mobility possible within the home business environments. Types of wireless networks: WPAN, WLAN, WMAN, W1. So WPAN is a wireless personal area networks, uses low-powered transmitters for a short-range network, usually 20 to 30 feet or 6 to 9 meters. Next is WLAN or wireless LANs, uses transmitters to cover a medium-sized network, usually up to 300 feet. WMAN or wireless MANs uses transmitters to provide wireless service over a larger geographic area. W1 Wireless Wide Area Network uses transmitters to provide coverage over an extensive geographic area. Wireless technologies: the Bluetooth, WiMAX, cellular broadband, and satellite broadband. The Bluetooth, an IEEE 802.15 WPAN standard that uses a device pairing process to communicate over distances up to 300 feet. So it can be found in smartphone devices, audio connections, automobiles, and other devices that require a short distance connection. So there are two types of Bluetooth radios, the Bluetooth Low Energy or BLE and the Bluetooth Basic Rate Enhanced Rate or BREDR. The WiMAX. WiMAX or Worldwide Interoperability for Microwave Access. So WiMAX is an alternative to broadband wired internet connections competing with DSL and cable. Cellular broadband. Cellular or the 4G, 5G are wireless mobile networks primarily used by cellular phones but can be used in automobiles, multi-access networks carrying both data and voice communication. Satellite broadband provides network access to remote sites through the use of a directional satellite dish that is aligned with a specific geostationary Earth orbit satellite. So, 802.11 standards. The world of wireless communication is vast. However, for particular job-related skills, we want to focus on the specific aspects of Wi-Fi. The best place to start is with the IEEE 802.11 WLAN standards. These standards define how radio frequency are used for wireless links. Most of the standards specify that wireless devices have one antenna to transmit and receive wireless signals on the specified radio frequency. So, some of the newer standards that transmit and receive at higher speeds require access points or APs and wireless clients to have multiple antennas using the multiple input and multiple output (IMO) technology uses multiple antennas as both the transmitter and receiver to improve communication performance. Up to 4 antennas can be supports. So here are the IEEE WLAN standards, the different types, and radio frequency, and also, of course, the description. So radio frequency. So as you can see here, all wireless devices operation in the radio waves range of the electromagnetic spectrum, while the networks operate in the 2.4 GHz frequency band and the 5 GHz band. Wireless LAN devices have transmitters and receivers tuned to specific frequencies of the radio waves range, as shown in the figure. Specifically, the following frequency bands are allocated to 802.11 wireless LANs, 2.4 UHF, 802.11 BGNAX, and 5GH7 SHF S02.11 ANACAX. So these are the figure, the electromagnetic spectrum. Next is the Wireless Standards Organization, the ITU-IEEE Wi-Fi Alliance. So these are their logo, the ITU, IEEE, and the Wi-Fi. So ITU, or the International Telecommunication Union, regulates the allocation of the radio frequency spectrum and satellite orbits through the ITUR. ITUR stands for the ITU Radio Communication Sector. And the IEEE specifies how radio frequency is modulated to carry information. It maintains the standard for local and metropolitan area networks are MAN with the IEEE 802 LAN or MAN family of standards. The dominant standards in the IEEE 802 family are 802.3 Ethernet and 802.11 WLAN. In Wi-Fi or Wi-Fi Alliance is a global, non-profit industry trade association devoted to promoting the growth and acceptance of WLANs. It is association of vendors whose objective is to improve the interoperability of products that are based on the 802.11 standard by certifying vendors for conformance to industry norms and adherence to standards. In WLAN Components, Module 12.2, WLAN Components describe the components of a WLAN infrastructure, wireless NICs. So here it is, the USB wireless adapter. Wireless deployment require a minimum of 2 devices that have a radio transmitter and the radio receiver turned to the same radio frequency. And devices with wireless NICs, a network device such as a wireless router or wireless AP. So to communicate wirelessly, laptops, tablets, smartphones, and even the latest automobiles include integrated wireless NICs that incorporate a radio transmitter or receiver. However, if a device does not have an integrated wireless NIC, then a USB wireless adapter can be used, as shown in this figure. So many wireless devices you are familiar with do not have visible antennas. They are embedded inside smartphones, laptops, and wireless home routers. Next is wireless home router, the type of infrastructure device that an end devices associates and authenticates with various based on the size and requirement of the WLAN. So for example, the home user typically interconnects wireless devices using a small wireless router as shown in the figure. The wireless router serves as an access point, switch, and router. So wireless access points, AP categories, topology and explanation of each type, Autonomous APs, these are standalone devices configured using a command line interface or a GUI as shown in the figure. Just understand this figure. Controller-based APs, these devices require no initial configuration and are often called lightweight APs or LAPs. Use the Lightweight Access Point Protocol or LWAPP to communicate with WLAN controller. As shown in the next figure, controller-based APs are useful in situations where many APs are required in the network. As more APs are added, each AP is automatically configured and managed by the WLC. So notice in the figure that WLC has 4 ports connected to the switching infrastructure. These 4 ports are configured as a link aggregation group or lag to bundle them together, much like how a third channel operates. Lag provides redundancy and load balancing. All the ports on the switch that are connected to the WLC need to be trunking and configured with Ether channel on. However, lag does not operate exactly like Ether channel. The WLC does not support Port Aggregation Protocol or PAGP or Link Aggregation Control Protocol or LACP or LACP. Wireless antenna. Wireless antenna, click this antenna for more information. Omnidirectional antennas, directional antenna, and MMO antennas. So you can read the following. Okay. Next is WLAN operation. The WLAN operation. WLAN operation includes 802.11 wireless topology modes, BSS and ESS, 802.11 premise structure, CSMA-CA, wireless client and AP association, passive and active discover mode. So you can browse the following here at Cisco Packet or Cisco Application Net ACAD. So you can watch the video. You can read some of these. So click each wireless topology mode for more information. Click, just read the following. So for us to know this structure or this figure, just analyze it well. CSMACA, wireless client and AP association, passive and active discover mode. Click mode for more information. And that's it. In Module 12.4, CapWAP operation, explain how a WLC uses CapWAP to manage multiple APs. So, introduction to CapWAP. CapWAP is an IEEE standard protocol that enables a WLC to manage multiple APs and WLANs. CapWAP is also responsible for the encapsulation and forwarding of WLAN client traffic between an AP and a WLC. CapWAP is based on LWAPP but adds additionally security with datagram transport layer security or DTLS. CapWAP establishes tunnels on user datagram protocol or UDP ports. CapWAP can operate either over IPv4 or IPv6 as shown in the figure but uses IPv4 by default. IPv4 and IPv6 can use UDP ports 5246 and 5247. However, CapWAP tunnels use different IP protocols in the frame header. IPv4 uses IP protocol 17 and IPv6 uses IP protocol I136. So this is the figure. And this is what I discussed to you guys. Next, Module 12.5 Channel Management. Describe channel management in WLAN or WLAN. And Module 12.6 WLAN threats. Describe threats to WLANs. Module 12.7, Secure WLANs or WLANs, describe WLAN security mechanism. So, Chapter 12 or Module 12, the WLAN concepts includes the introduction to wireless, WLAN concepts, or WLAN components, WLAN operation, CAPWAP operation, channel management, WLAN threats, secured WLANs. Okay, so thank you guys for watching this presentation or video. So for you to know more about networking or this module WLAN concepts, just go here at, what you call that? The Cisco Net Acad. You can log in your account for you to be able access the following.